First, we will see its dependence in liquids. We discussed that liquids are flowing layers like this. Okay, and why is this layer dragging this layer? Why is this layer dragging this layer? The reason is there are very strong intermolecular attraction forces. Now, what happens is when we increase the temperature, these molecules they get more energy and they can escape these attractions. And when these molecules escape these attractive forces, this layer can freely slide on this layer. This layer can freely slide. And so, what happens is for liquids, with increase in temperature, viscosity coefficient decreases. Next, let us look at viscosity in gases. In gas, as the molecules are very far apart, the intermolecular forces are very weak. Okay. So how does gas transfer momentum? Tell me. In liquid, what happened? One layer, it is dragging the other layer. In why is it dragging? Because there are strong intermolecular forces of attraction. Gas, the molecules are very far apart, so they can't apply sufficient intermolecular forces. So what happens is in gas, what see one molecule it collides with other molecules and this drags or gives the momentum to the other molecules. So if this is one layer, you think of this cube which is there here as one layer. It comes and strikes the other, and that is how momentum is transferred. Now this is at a given temperature. Many of these gas molecules are very slowly moving. Suppose you start increasing the temperature, the ones which are there here they start vibrating very randomly, very fast. They vibrate very fast, and because they vibrate very fast, this layer which is there, no, this undergoes even more collisions with all this, and because it undergoes more collisions, it can't slide past freely. So at high temperature, for gases, the viscosity increases. For liquids at high temperature, the viscosity decreases. For gases at high temperature, the viscosity increases.